All right, here we go, continuing with the notes, and we're going to learn about reference angles. And when we talk about reference angles, we're always talking about quadrant 1, 2, 3, and 4. And a reference angle is going to be the angle that is closest to the x-axis. So it's going to be the angle closest to the x-axis. So let's think about quadrant 1. Right, if we have an angle in quadrant 1, it'll look like this, and of course it can look like this, it can look like this. Right? And then you have to think about it. The x-axis is here and the x-axis is here. Which way is it closer? This way or this way? Obviously this way is closest because it's a shorter angle or smaller angle. All right, so then this one is going to be your reference angle, or theta r. Don't worry about the symbol right now. Theta is going to be a variable that we're going to use to represent our angles. Just kind of like x or y. It's just a Greek letter and it's called theta. Theta. And then a sub r for reference. But this is also actually the angle, right? Because we always start measuring from here and we end at the terminal side. So for quadrant 1 in degrees, your reference angle is the actual angle. Okay, it's the angle. That means angle. And of course, if you're in radians, then it's the same thing. It's the angle. So whatever the angle is in quadrant 1, it is its own reference angle. So if this was 30 degrees, then the reference angle is 30 degrees. All right, let's talk about quadrant 2. All right, if you have an angle in quadrant 2, then it's going to look like this. And of course, it can look like this, or it can look like this. The whole point is that you have an angle in quadrant 2. Now, where's the x-axis? All right, your x-axis is here, and your x-axis is here. Where is it closer? From here to here, or from here to here? You can see that this one is closer, right? So this one is going to be the reference angle. We'll call this one theta sub r for reference angle. So when you're in quadrant 2, you're always going to start from this side up to the angle. That's going to be your reference angle. Well, you may not know that one, right? So this angle can either be measured from here or from here. So how do we find it? Well, if you happen to know this angle, you also happen to know, not yellow, green, that this whole thing is 180 degrees, right? So what do? Right? Let's say this is your angle. You happen to know, I want it black. You happen to know the angle. So how do we find this one? Well, take 180, we subtract this angle, and you've got the leftover. So that would be 180 minus the angle will give you your reference angle. Right? So 180 minus the angle. Right? The angle being this one. So make sure you sketch this drawing. That way you know what this means. And in radians, well, what's 180 in radians is pi. So it'd be pi minus the angle. We'll give you the reference angle. This one right here. All right, let's do this for the third quadrant. If you're in the third quadrant, then your angle is going to be like over here. Obviously, it could be this one, it could be this one. It doesn't matter, as long as you're in the third quadrant. And where is your x-axis? Well, the x-axis is here, and the x-axis is here. Where is it closest? Right here or right here? Obviously this one. This one is closest or closer to the x-axis. So this one is the reference angle. Well, then how do we find it? Well, usually you know the angle, right? The angle starts here. We always start here, right? This is your angle, right? And you also happen to know that this is 180 degrees. So how do we find this part right here? Well, you take the entire angle, take away the 180, and you've got the leftover. So it's going to be, using black ink, it's going to be the angle minus the 180 degrees, and that's going to give you the reference angle. So when you're in quadrant 3, it's the angle minus 180 degrees. Or if you're in radians, the angle minus pi. All right, the last quadrant. Remember, the reference angle is the one that's closest to the x-axis. So if you're in the 4th quadrant, you could be over here. So where are your x-axis? It's going to be this one or this one. So where are you closest to? This way or this way? Obviously the first one, right? So this one's going to be our reference angle. Well, how do we find it? Well, we normally know, remember the angles start from here. We normally know the angle. And we usually know, well, actually we always know, that going around the circle would be 360, right? So if you take the 360 and you take away the angle, what do you have left over? The reference angle. So it would be 360 minus the angle. It's back and forth between color. Is going to give you the reference angle. So it's not about memorizing the formulas, it's just about you understanding how to find it. So if you're in quadrant 4, you take 360 and you subtract the measurement of the angle in the 4th quadrant and you get the reference angle. You get this little one in red. And if you're in radians, so that would be 2 pi minus the angle. All right, let's do some examples. All right, let's see if we can do this. Make sure you have your calculator handy so that you can follow along. Negative 605. All right, so we need to visualize. I need to visualize. It's obviously clockwise, right, because it's negative. But how many times did it go around the circle? So let me do a little cheat trick. If it went once around the circle, that's 360, right? So I'm going to add 360 to this number, minus 605 plus 360. Make sure you're doing this with your calculator. Otherwise, it's futile. So I got minus 245 left over. So I've gone once around the circle, right? But I still have negative 245 degrees to go. Well, that's not fully a circle, right? Because that's not 360. But that's half a circle. So plus 180. Right, so that's minus 65 left over, and I went like this. Another half circle, right? And I've only got 65, and that's less than 90. So that means, let me change the color ink, that it is this 65 right here, and this is my reference angle. And I'm in quadrant 2. And I know it's not asking you for the quadrant, but I'm in quadrant 2. All right, let's do this again. This is 580, so that means I went counterclockwise. And it may not be so evident. It might be for some of you, but how many times did I go around the circle clockwise? All right, so I've got 580 degrees, right? Let me go around the circle once, because I know it's, so let me take away 360 degrees because I went around the circle once. So 580 minus 360 gives me 220. Now 220 is not quite 360, but it's definitely half a circle, 180. So I'm going to go take away 180. Let me see, 220 minus 180. That leaves me 40 left over, and let me go. So I was here, and I went 180. So now I'm here, but I still have 40 more to go. Well, this 40 is less than 90. Oh no, here it is. I'm looking for that little mouse, little cursor thingy. So this is 40, and so that means that that's the reference angle, 40 degrees, and I'm in quadrant 3. Okay, 17 pi over 12. Let me clean up some of this chaos right here. Delete. All right, looking at number 11, we have 17 pi over 12. I'm going to go slow on this one. So then the question is, what is the reference angle, or where is this? So take the 17 over 12 and turn that into a mixed number. Well, 12 goes into 17 one time, and we've got 5 left over, right? So this means 1 pi in 5 out of 12 pieces. And it's positive, which means we win counterclockwise. So this 1 represents this one, half a turn here, 1 pi, right? This is a pi. This is 1 pi right here. And then 5 twelfths. Well, this over here, this entire pi, and we're talking about the third quadrant and the fourth quadrant. If you break it off into 12 pieces, then each quadrant would be 6 pieces, right? I'm going to get a green marker, and I'm going to do this, right? I'm talking about the entire pie left over. If I break it off into 12 pieces, then each quadrant would be 6 pieces, right? 6 pieces, 6 pieces. So where would I have 5 of those pieces? Well, it would be somewhere here. Is where, so this would be 5 pieces plus 1 would give you the 6 pieces. So this angle right here would be the part that's left over, the 512. Right, so the 512 pi would be your reference angle. And that would be in quadrant 3. All right, let's look at the last one. The last one, we have 19 pi over 6. All right, so let's look at the 19 over 6. And let's turn that into a mixed number. 6 goes into 19 3 times. And then 6 times 3 is 18. From 19, you got 1 6 left over, right? So that's 18 plus 1 is 9. So it's 3 pi's. So if you look, this would be 1 pi, 2 pi's, 3 pi's, right? So that takes care of this number. And then 1 6. So now, if you think of this entire pie over here, right, the 2 quadrants, as 6 pieces, that means each quadrant would be 3 pieces. So where would you find one of those 6 pieces? Right here. Right, so this would be 1 6 pi, right? 1 plus 2 more gives you 3 pieces, right? So this is your reference angle right here, 1 6 pi, and you would be in quadrant 3.